Hi, my name is Coach Cowland, and in this video we're going to be looking at acceleration. So we're going to start by asking the question, what is acceleration? Is it how fast something goes? Well, we've already talked about that. That's actually speed, so it can't be how fast something goes. So let's address this question by looking at an example. So here we have a picture of two pictures of cars, and I'm asking the question, what is the difference between these two cars? Now you could come up with lots of differences between these two cars. They're very different. But in terms of motion, what would you say? Probably the first thing that's going to come to your mind is you're going to say one goes faster than the other. Well, yes they do. One does definitely go faster than the other one, but that's a measure of speed. Now if both of these cars were at the lights and the light changed to green and the drivers hit the gas, which one would get away quicker? I'm guessing that the one on the left would probably get away quicker because its velocity would increase that much faster. And that is what acceleration is. If you've ever heard someone talking about that a car does 0 to 60 in so many seconds or something like that, what they're actually talking about is a change in velocity, a rate of change in velocity specifically, and that is what acceleration is. Now, if we were talking about getting from 0 to 60, both cars would get from 0 to 60. The Volkswagen Beetle might just get from 0 to 60, but it would get there eventually. And the car on the left would get there much quicker. Now, it's not the 60 and the 0, it's how fast it gets from one to another that gives you acceleration. Being more specific, acceleration is the rate of change of velocity. The rate is the key word here, which is why I've highlighted it in yellow. It's really important. It's the word that people miss. So if you make a note, make sure you double underline, highlight it, and boldface it and whatever, and make sure that that's what you're emphasizing. It's the rate of change of velocity. And acceleration can occur in three separate ways. Acceleration is when the velocity increases over a period of time. It's when it decreases over a period of time, or it's when your direction changes. Now, you could be lulled into this whole idea of acceleration is speeding up and deceleration is slowing down. In physics, we don't use the term deceleration. It's just negative acceleration, and we'll see why that is in a minute. So in terms of speeding up, when the acceleration is in the same direction as the velocity, something's going to go faster. Its velocity increases. Now this little blue car started off with a velocity of 0, and then it increased and its velocity increased, and that's because its acceleration was in the same direction as the velocity. If the acceleration is in the opposite direction of the velocity, it will cause the car to slow down. It will cause the object to slow down. So the acceleration acting opposite to velocity will mean that the opposite thing will happen, and instead of speeding up, it will slow down. The velocity will decrease. Now, the other way that acceleration can occur is that it can cause a change in direction. A change in direction means that there is an acceleration happening. If something is going in a circle like the Earth or around the Sun, then it is accelerating. And the acceleration is to do with the direction that it's moving. So here we have the red arrow going at a diagonal up, which means that the acceleration is upwards, and the yellow diagonal arrow going towards down, and that means that the acceleration is downwards. So that's how the acceleration affects the change in direction. Putting this mathematically, delta v is the change in velocity. V minus v naught is the final velocity minus the initial velocity. Now, I already said that acceleration is not delta v, the change in velocity, but it's the rate of change in velocity. So that means a is equal to delta v divided by t, or the difference in velocity divided by the time it took to get there. So v minus v naught divided by t. Because acceleration is the rate of change of velocity, it's actually velocity divided by time. So if we take the units of velocity, which is meters per second, and then we divide it by the units of time, which is seconds, you get meters per second squared. What causes acceleration? Well, in order to answer this, let's look at an example. When is the time that you find things accelerate most? When they change their speed the most? And this can be from 0 to something. Generally speaking, it's when things fall. If something falls, it usually starts at a velocity of 0 and gets progressively faster until they hit terminal velocity, but that's another story. So when something falls, it accelerates. So what causes things to fall? Other than clumsiness, you could say clumsiness causes things to fall, or cats. I would say the primary cause for things falling is gravity. Right? Gravity causes things to leave your desk and end up on the floor. And what is gravity? It's a force. This leads us to the notion that acceleration occurs when a net force acts on an object. A net force is just when you put all of the forces together and they end up all acting in sort of, some of them cancel out and some of them don't, and you end up with a force going in one direction. And the key thing about this is acceleration is in the direction of that net force. So for example, going back to the desk example, if I drop my pen off the desk, then yes, there is air resistance which is acting up on the pen and it's causing it to slow down just a tiny little bit. But the net force, but because gravity is a far greater force, it is still acting downwards more than it is acting upwards with the air resistance. So the acceleration of the pen is getting faster downwards because gravity is going downwards. Net forces and accelerations are always in the same direction. Now equilibrium is when there are no net forces acting, and if something is in equilibrium, it is not accelerating. So you can tell that there are no net forces acting if the acceleration is 0. This is really important. If your car is traveling down an exactly straight road, which means that there are no bends and no turns, and you're traveling at 70 miles an hour, even if you have your foot somewhat on the gas to keep it at 70 miles an hour, you are in equilibrium, which means you are not accelerating, even though you have your foot on the gas and you are, to apply the verb, accelerating. But your car is not accelerating. Now we're going to talk about this more in forces, and this is this is Newton's second law in motion. But the cause of acceleration is a force, and the acceleration is in the direction of that net force. Okay, thank you.